Okay, in this video I'm going to finish up solving radical equations. So on number 10 and 11 here we have two radicals in the equation, so we're going to treat these a little bit differently. We need to make sure we have one radical on each side. So on number 10, the first thing we're going to want to do is subtract square root of x plus 2 from both sides. So we get the square root of x minus 3 is equal to 5 minus the square root of x plus 2. And so now we can go ahead and square each side. Now when we square the left side, that's pretty easy. We're squaring a square root. We're going to get the x minus 3 there. But on the other side, we're going to have to FOIL that. We're going to have to multiply two of those out. Well, we actually already did that right here. And so I'm just going to go ahead and put that answer right there. A lot of times for a situation like this, I'll do that work off to the side, and it just makes things cleaner in the actual equation. So let's just plug in what we got on letter F up above. Now we basically treat this as if it were, well, it is now an equation in one radical, and so we want to isolate the radical. So I want to get rid of that 27 and the x term first. So let's subtract x from both sides and 27. We're going to get negative 30 is equal to negative 10 times the square root of x plus 2. Now since it's negative 10 times the square root of x plus 2, we can get rid of that negative 10 by dividing. And fortunately on the other side we get 3, which is quite a nice number. And so now we're ready to square both sides. We're going to get 9 is equal to x plus 2, which means x is 7. And let's go ahead and check that. So we have the square root of x minus 3, or in this case we're plugging in 7, so the square root of 7 minus 3 plus the square root of 7 plus 2 equals 5. Well, that's going to be the square root of 4, which is 2, plus the square root of 9, which is 3. And so that does equal 5, and so 7 is a good answer. So you may want to try number 11 first and see if you can do it, and then watch the video. All right, so we've already got the radicals on opposite sides, so let's go ahead and square each side. We have the square root of 2x minus 5, quantity squared, is equal to 1 plus the square root of x minus 3, all of that squared. And so we get 2x. Well, actually, I'm going to go ahead and do the right side over here. So I got to multiply two of these 1 plus the square root of x minus 3. And when we FOIL, we get 1. We multiply the 1's here, and then we'll multiply here, and we get 1 square root of x minus 3. Our inner product here will also be the square root of x minus 3. And when we multiply these two here, square root of x minus 3 times the square root of x minus 3 is going to be x minus 3. We're squaring basically the square root of x minus 3. All right, so, and that's what we had practiced up above, and B was an example. When you multiply a square root times itself, you get the radicand that's inside. All right, so let's simplify this. We've got the 1 and the minus 3. That's going to make a minus 2. 1 minus 3 is negative 2. And we've got 1 square root of x minus 3 plus another 1 square root of x minus 3. So that's going to be 2 square root of x minus 3. And don't forget the x there. And so now I'm ready to simplify the equation. So on the left we have 2x minus 5. And we just took care of the right side. We have negative 2 plus 2 square root of x minus 3 plus x. All right, so now we have one radical. We need to isolate that radical. We're going to want to get rid of the minus 2 and the x. So I'll take care of that first. And so we're just adding or subtracting x on both sides and adding 2 to each side. We get x minus 3 is equal to 2 times the square root of x minus 3. Now, you might normally what we'd want to do is divide by 2 here and get that radical all by itself, but in doing that we would have x minus 3 over 2, a fraction. So you can do it either way, but I think most people find it a little bit easier to just square the right side as it is, because we can square this and it'll be a little bit easier perhaps. So we're going to square the left side, x minus 3 quantity squared. I'm going to go ahead and do that work on the right over here. So x minus 3 times x minus 3, you're going to get x squared minus 3x plus 9, which is x squared minus 6x plus 9. And on the right side, we're going to multiply 2 of these 2 times the square root of x minus 3. And the nice thing about multiplication is we can multiply the numbers in any order we want. In fact, I can't multiply the 2 with the x minus 3 because it's inside the radical. Now, if it was the square root of 2 times the square root of x minus 3, I could. But it's not. So what I'm going to do is put my 2's together and my radicals together. 2 times 2 is 4. And the square root of x minus 3 times the square root of x minus 3 is x minus 3. Now you do need the parentheses there because it's 4 times that binomial. And so we're going to get 4x minus 12. So let's go ahead and on the left we'll plug in our x squared minus 6x plus 9. On the right we'll plug in our 4x minus 12. Notice we have a quadratic equation, so we want to get 0 on one side and everything else on the other side. So let's subtract 4x on both sides and add 12 to both sides. We're going to get x squared minus 10x plus 21 equals 0. And this is a trinomial that we should be able to factor using the AC method, or certainly that would be our first choice. So we need 2 numbers that multiply to 21 and add to negative 10. Let's see. That's going to be 3 and 7. Notice they'll both need to be negative. Negative 3 times negative 7 is 21. And negative 3 plus negative 7 is negative 10. All right, so let's plug in those numbers. And when we solve, we get x is 3 and 7. And I would encourage you to check those. They do work. I've kind of run out of space to show you, but if you check them, they do make the equation true. Let's move on. All right, on number 1 here, we're going to want to cross multiply. We have a proportion there. Now, notice we're solving for f, so we want to get f by itself. But before we do that, we need to take care of the fractions and clear fractions. We can do that by cross multiplying. We get f times ab, that's this cross product, is equal to this cross product here. So that would be CDE. And so now I just need to get rid of the a and the b there. It's f times a times b. By dividing by AB, I can cancel on the left, and I'll divide by AB on the other side. And so I end up with F on the left and CDE over AB on the right. On number 2, I'm going to need to find a GCF first, an LCD. And since they're all letters, the only thing I could do is actually multiply them. So notice we're solving for f. Our LCD is FMP. So we're going to multiply each of our terms by FMP. So on the first one there, 1 over f, when we multiply, the f's will cancel, and we're left with MP times 1, which is MP. On the other side, our m's are going to cancel when we multiply by 1 over m. And we're left with FP times 1, or just FP. And then on the next one, let's see, our p's are going to cancel, and we're left with FM, with a plus in between the 2 terms there. Now, you got to think a little bit about this carefully. Notice FP and FM are not like terms, so I can't add them together. They don't have the same variable factors. They both have an F, but that's all that they share. So how am I going to get f by itself? Well, hopefully factoring out the GCF comes to mind, because that's what's going to work here. They both have an f factor, each of these terms. So we can factor out an f. F times p would be fp, and f times m would be the fm. And see, now we can divide by p plus m, and now we can solve for f. All right, number 3. So again, when we solve these kind of equations, we're really just rearranging them, and we're using our equation skills. The thing that sometimes makes it hard is it's just all letters, which is something we're not really used to. All right, number 3. I want to get to the end, but the radical's in the way. I can't just divide by 3p here. What I can do, though, is square both sides. Again, we're trying to solve for n, so let's square both sides first. We're going to get r squared equals 3np. And now you can see we have 3np times n on the right. We can divide by 3p on both sides. And notice we're left with n equals r squared over 3p. And finally, on number 4, we're solving for c. So again, we got to get rid of the radical. Let's square both sides. And we're going to get w squared equals 1 over lc. I've still got to clear fractions here. I want to get rid of the fraction. In fact, my c is in the denominator. So let's multiply by the LC. That's our only denominator. And when we do that, notice on the right side, the LC's cancel and we're left with 1. On the left, we have LCW squared. And now we're ready to solve for c. We need to get rid of that L and the W squared, which are multiplied times c. So we'll divide. And so we're going to end up with c equals 1 over LW squared. And that's it. Let's go ahead and stop because we are done.